Hey everybody, Mr. Judson here. Alright, we're moving into Chapter 5, so we have some new stuff to look at. But just to start us off, I want us to see if we can solve this integral. Okay, you guys go ahead and try it. Alright, so we've seen integrals like this before. Our first thought is we split it up into two different fractions. So I would say this is the same as the integral of x squared over x minus 1 over x dx, which I'll go ahead and cancel an x with an x, so this will become just the integral of x, and this we'll write as x to the negative 1. And so then we add 1 to the exponent and divide by the new exponent, so that would be x squared over 2 minus, I'll add 1 to this exponent, so I'm going to get x to the 0 power over 0, plus c. And I guess I look at that and I think to myself, what am I going to do with that? Because you can't have 0 in the denominator, right? That's already undefined. We know that anything to the 0 power is 1, but 1 over 0, that doesn't work. So someone might think, well, the answer is there's no solution, or undefined, or something like that. Well, no, there is a solution. There is a solution. Remember how I told you guys I always think in my head, what did I take the derivative of to get to something? What would I take the derivative of to get to this? That's a derivative of a natural log of x, right? If I just kind of go over here off to the side, let's see, d dx of a natural log of x, well, that just equals 1 over x. U prime over u, right? That's one of our derivatives that we learned. And if I was taking the derivative of a natural log of u, which means any expression that has x's in it, well then my answer was u prime over u. So that's what I want to do, is I just want to go from this back to this. We just have to recognize when that happens. So there is one slight thing we got to be careful of, though. And I don't know if you guys remember this. We said, when we first did derivatives, we said if you put absolute value signs in here, it's still the same answer, right? If I had the absolute value of u, my answer is still u prime over u. Well, when you go the other direction, you have to make sure that what you get here is positive, because you can't take the natural log of a negative number. You get an error message. You can try it on your calculator and see. Okay? So we have to make sure we get something positive. So when we do an integral and go the other direction, we have to put those absolute value signs in there. Okay? So this is our main focus right here for today. Is if I'm going to do an integral of u prime over u dx, so the reason we put dx here instead of du is because both of these are expressions with x's in them. All right? Sorry about my phone going off. So if I didn't already tell you this, I became a grandpa yesterday. I think it happened right during second period's exam. They were sitting here and I went, "It's a boy!" So yeah, so anyway, there's a lot of chatter on my phone just amongst the family that everybody's all excited. So anyway, that's what's going on. All right, so I know I'm going from this back to here, but the main thing is you cannot take the natural log of something negative, so we have to put those absolute value signs in there, and then plus c. Okay? Absolute value signs have to be there unless we can look at it and say that's obviously a positive number. If I had something like the natural log of x squared, Well, when you square something, it's always positive. Then you could leave the absolute value signs off. But what a lot of people choose to do is just leave them there because that way it's always right. Okay? So if I back up to this right here, let me get rid of this. What I really should have done is looked at that and said that's going to be a natural log absolute value of x. Okay? We're not even going to look at this right here. We're just going to go from this straight to there. All right, that's our focus for today. Being able to do integrals where we've got u prime over u and get natural logs as answers. Let's try another one. All right, so this is actually one of my favorite integrals, integral formulas, because I feel like it's the easiest one to do. All I have to do is look at this and say, can I get the derivative of this up here? And if the answer is yes, well then I'm just going to have a natural log absolute value of that denominator. So anytime I see a fraction, no parentheses, okay? No parentheses raised to an exponent. When I see a fraction, just a fraction, I'm automatically thinking this is a natural log problem, okay? So I look at this and say, well, what's the derivative of that denominator? The derivative would be 4. Okay, I don't see that in the numerator, but I could make it a 4 if I just multiply by 4 and then divide by 4 out here, right? Because if I move that 4 out here, I've got 4 over 4, which is 1, and I haven't changed the value. So now I've got u prime over u, so my answer is 1/4 natural log absolute value of the denominator plus c. All right? Remember, all we're looking for is, can I get the derivative of the denominator written up here? If I can, then the answer is the natural log absolute value of that denominator. That's what we're looking for. If we can make it happen, these can be really quick, easy problems. Okay, let me get you guys one to try. All right, you guys go ahead and try this one. All right, so I just take a look at this and I think to myself, what's the derivative of that denominator? It's 2x. Can I make that happen up here? Yep. Put a 2 in, put a 1/2 right there, and my answer is 1/2 natural log absolute value of x squared plus 1 plus c. Now, this is one where I could have left the absolute value signs off. I could have just put parentheses. Because when you square a number, that's positive. Add 1 to it, you just made it more positive. So there's no way you can make this negative. So we could have said natural log and then in parentheses x squared plus 1 and been okay. All right, let's try another one. Yeah, so we knew they couldn't all be that easy, right? So here we've got the integral of x squared plus x plus 1 all over x squared plus 1. And the derivative of this is 2x. Well, that's not going to happen. Okay? So here's a rule that we have to make sure to remember. Anytime we're doing an integral and the exponent in the numerator is equal to or larger than the one in the denominator, then what I need to do is I need to do long division. I need to divide this and find an equivalent expression. So off to the side here, I'm going to do this divided by this. So x squared plus x plus 1 divided by x squared plus 1. All right, so x squared goes into this once. Multiply back, you get x squared plus 1. I want to line up that one with this one and then subtract that. You guys remember this from last year? Long division. So let's see, this minus this, that's 0. X minus nothing. And then 1 minus 1, that's 0. So I'm going to write this as, since that's positive, I'm going to write it as plus x divided by this. Okay, if you got your notes from last year, it might be worth going back and looking at some of those long division problems. That would have happened with polynomials. It was during first semester, I know that. Don't remember exactly when or what chapter, but it's during first semester. So this right here is an equivalent expression to that. So if I solve that integral, 1 plus x over x squared plus 1 dx, then I'm really getting the same answer as we would have for this thing right here. So I would divide this up into two separate integrals. Integral of 1 dx plus the integral of x over x squared plus 1 dx. And we know this one. That's just a constant, so the answer to this is 1x, or just x. Over here I'd look at this and say, could I make this a u prime over u? And yeah, we could do that if we multiply by 2 and divide by 2. Now I've got u prime over u, and so my answer here is going to be 1/2 natural log absolute value of x squared plus 1 plus c. Which, again, those absolute value signs could have been left off because that's guaranteed to be positive. All right, so anytime we see the exponent in the numerator where it's equal to or larger than the denominator, we have to do long division. All right, let me get you guys one of those to try. All right, you guys go ahead and see if you can solve this one. Got my dx there. So long division, exponent's larger, so let's do that off to the side. I've got x cubed plus, there is no x squared term, so you put a 0 in there kind of as a space filler. And then minus, instead of doing long division, could I do synthetic division? Right, because we're just dividing by x plus or minus some number. That's when you could use synthetic division. You could do long division, it'll work. But synthetic division will be a little bit quicker. So if I write down my coefficients, 1, 0, -6, -20, and I'm dividing by x plus 5, that means I want to use whatever makes this equal 0. So -5. So you bring down the first number, multiply, you get -5, add these up, multiply here, you would get positive 25, add those, you would get 19, multiply here, you get a negative 95, add these, you get a negative 115. So that means that my answer to this is going to be x squared minus 5x plus 19, right? These are the coefficients of a polynomial where my degree is 1 less than this, so starting at x squared. And then minus 115 divided by x plus 5. That's the integral I have to solve. And at first, you might have looked at that and said, oh, that looks hard. But it's not hard. Add 1 to the exponent, divide by the new exponent. Minus, add 1 to the exponent, divide by the new exponent. Plus 19x. And here I'm going to write this as an integral of 115 over x plus 5 dx. The only reason I'm writing this as an integral is because I like to see the u prime over u. If I can see it, then I know I've got things right. So I think what I would do here is I would move that 115 to the outside and just have that be a 1. So what's the derivative of the denominator? It's 1. I've got that up here now. And so that means that my final answer is going to be this. X cubed over 3 minus 5x squared over 2 plus 19x minus 115 natural log absolute value of x plus 5 plus c. And you can check these on your graphing calculator, right? If it's an odd one and the answer, or the odds are in the back of the book. If it's an even one and the answer is not in the back, well, just put it in your calculator and see if you got it right. Okay? We all know, don't use your calculator to do the problem. Use it as a way to check and make sure that our thinking is moving in the right direction. All right, let's go ahead and try this one. All right, so I'm wondering if maybe I caught you on this one. I mean, we get used to doing this. So we're looking for u prime over u, and we want every problem to be like that. But this isn't just a fraction. I've got something inside parentheses raised to an exponent, which to me that says substitution. And again, they're going to throw a couple of these in there just to make sure we're paying attention. Okay? Are we remembering what we've already learned? So if I was to rewrite this like this, x plus 1 raised to the negative 2. I'm going to move that 2 to the outside, and I've got this x dx here. And let's see, so if I let u, let's go off to the side here and say let's let u equal x plus 1. That means du is going to be just 1. And I just took the derivative of x. And according to this, if I move that 1 over, u minus 1, that's equal to x. Because it looks like we're going to have to do a change of variable here. Right? All right, so what I have now is 2 times the integral of u to the negative 2 times u minus 1. We're going to put that in place of x. And then du is equal to dx. So now if I go ahead and distribute that, I've got 2 times the integral of u to the, let's see, if I add the exponents, I've got negative 2 plus 1, that's negative 1. And then when I multiply here, I've got minus u to the negative 2 dx. Oh, du, sorry. That should have been a du right there. All right, so I add 1 to the exponent, I get 0, divide by the new exponent, dividing by 0, uh-oh, can't do that. This is really the same as 1 over u, right? So isn't that u prime over u? So this is going to be the natural log absolute value of u. And over here, when I add 1 to the exponent, I get u to the negative 1 divided by the new exponent plus c. Still got 2 times all of that. So that means I've got 2 natural log absolute value of, what was that, x plus 1? Yeah, u is equal to x plus 1. This is a negative divided by a negative, so it's plus. And then I got to drop this below the fraction bar, so 1 over x plus 1. And 2 times c is still some constant that we don't know. All right, that one made us think a little bit more than some of the others. And we will get some here that are going to make us think a little bit farther than some of those basic ones, but we should be able to get through these. All right, let's try one more. All right, let's go ahead and try this one. All right, so this one looks a little scary, but I think if we I look at it, I see a fraction. Let's think u prime over u first. I don't see any exponents here, so I'm looking at this as just a fraction. And I'm going to think of this as x squared plus 2x. I'll just go ahead and distribute that x to each of those. So when I take the derivative of this denominator, what I get is 3x squared plus 6x. And so the question is, can I make that happen right here? And yeah, I can do that if I multiply by 3. So I'm going to multiply this by 3. We'll divide by 3 out in front. So as soon as I do that, I get 3x squared plus 6x. That's what I need. And so I now have a u prime over u. Right? So I know that the answer to this is 1/3 natural log absolute value of that denominator. X cubed plus 3x squared minus 4 plus c. So that one really wasn't too bad. All right, that's it. That's what we have for today. Let me get you guys a homework assignment. All right, you guys, that's what we have for today. So here's our assignment. We are in week 6 now. There was no Monday piece because we were taking our exam. So this is our Wednesday piece. Page 330, we're going to do 5 to 27 odd, 51, 55, and 69. All right, that's it, you guys. Take care, stay safe. I will see you tomorrow. Bye.